We're going to now take a look at evaluating logarithmic functions, both common log and natural log functions. So let's first of all make sure we understand the difference between a common and a natural log. If you haven't seen the video 4.2a, you'd probably want to watch that before you continue with this one. But what we're going to do here is we're going to rewrite this logarithm in exponential form. So here's what we're going to do. If you looked at the previous video, you're going to probably say, Miss Savelle, how can we rewrite it? I don't even see a base. Well, this right here, when I see the word log with no base, I understand that to be a 10. So this right here is an understood 10. And that's what all common logs have. It's understood to be there. Okay? So we don't have to write it. So when I don't see a base on a logarithm with the word log, then I know it's a 10. So now that we know that there's a 10 there, let's rewrite it in exponential form. We have 10 to the power of y is x. 10 to the power of y is x. Now, that's a common log. Okay, now your calculator will calculate common logs. Okay, so it can calculate these kinds. So I'm going to put here calculator can do these. All right, the calculator cannot calculate a log other than a common log or a natural log. So let's take a look at the natural logs. So when I see a natural log, what I need to understand is that natural log has an understood e. So let me rewrite it for you and show you what it means. Y equals log with an understood e there. There's an e, and you're going, what in the world is an e? Well, it's actually an irrational number, kind of like pi, right? A pi is an irrational number, goes on forever and ever, the decimal, and e is about 2.7-ish, but it goes on forever. That's an estimation of e. So we're going to now, but we know that ln, let me just highlight this for you, ln is the very same thing as log with a base e. Those are the same things. So I'm going to write that here and here. This is the same as that. So when you see an ln, you know that that's a natural log, and it just is understood that the base is e. So let's rewrite it now in exponential form. Okay, this is how we could rewrite this. We could say e to the power of what? Y is equal to x. So that's what it means. All right, now that's helpful for graphing these. This is why this is what's really helpful for this, is to graph, using this to graph. The calculator can do common logs, and the calculator can do these. Okay, but a calculator cannot do any other logarithm other than a common or a natural. So let's take a look at evaluating these. Now, even though the calculator can do these three that I'm showing you, you need to be able to evaluate these on your own. So let me remind you, let me actually put this up here. The directions would say either evaluate or find the value. Something like that, okay? Find the value of the indicated logarithm, something like that. So let's take a look. If you notice, these are expressions. Now, what do we mean by expression? Well, it means it's not an equation. So what I'd like to do is I'd like to just turn it into an equation. So I'm going to set this equal to y. So we're going to say, okay, this whole thing is y. I don't know what that whole thing is, but it is equal to y, let's say. Now, if I know that the base that's really understood to be here, right, is a 10, okay, then now I can rewrite this equation in exponential form and then solve for y. So let me show you what I mean. We have base 10, power of y is equal to 10,000. Now, if you've watched my previous videos, which I recommend, then you'll know that now we can rewrite this so that it has a matching base of 10. So I could rewrite 10,000 as 10 to the 4th power, right? Now the one-to-one property of logs says, hey, because these bases match, what I'm allowed to do is to take the powers and set them equal to one another. And that just makes sense, right? Whether you know any math or not, that just says, hey, if those are in the same position, they have to equal each other. So y is equal to 4. Okay? Let's take a look at the next one. Now, when I look at this, I understand this really is saying this. This is and if you need to do this until you really understand what these are, then do this. This is really the same thing, right? This is the same as. All right, now let's take this thing and set it equal to 0. Now we have an equation that's a log that's an equation, and now I want to rewrite it in exponential form. Here we go. This is e to the power of y is equal to 1. Now think about it. Any number to a power that's equal to 1, what would the power have to have been? Right? It would have had to have been a 0. So this one we really can just kind of look at it analytically. We could also have done it this way. At this point I could have rewritten that as e to the 0 power, right? Because that's the same as 1, and then I would have said, okay, well that's e to the 0, that's a 0 then. Anyway, I think it's just easier on in this case. When you have something, a base raised to a power that's equal to 1, we know what that power has to be. It has to be a 0. Okay? Last one, and actually I'm writing it both ways to let you see this works for natural logs or common logs. So let's take a look. Let's go ahead and set this one equal to y. Let's rewrite it with an e there so we can take a look at what we have here. So we have e to the power of y is equal to -3. Now, I just want to quickly make a table of values, and I want to come up with a solution to this without having to use the calculator or anything else. Remember, on a logarithmic, we work backwards. So if we raise this to the 0 power, by the way, let's just forget about that. Let's see if we can get it to be a -3. All right, get it to equal a -3. So if it's e to the 0 power, and remember, e is just a number. It's approximately 2.7. Okay, approximately 2.7. So it is an actual number. It's not a variable. Kind of like pi. Okay, so that number to the 0 power, right, is going to be a 1. That number to the -1 power is going to be 1 over that, which is just a really tiny fraction. That number to the first power is going to be e. To the second power is going to be e squared, and on and on and on this way, and on and on this way. Am I ever going to be able to get this to be a negative number? Absolutely not. So right here, we're going to say no way. There's no way, right? There's no way that can happen. So same thing here. This is log base 10 of -3. And we're going to set that equal to y. Now we go 10 to the y power. Is that ever going to be able to equal a -3? No. Same thing is going to happen. This is not going to happen. Same thing is going to happen over here that happened over here. There's no way. So there's no solution here. When I say no solution, I mean it's undefined. There's no way it can happen because there's no y value there. And if you remember our log functions, they look either like this, right? Or they look like this. Now what does that mean? That means there's no way the x value can be negative. Okay? So we could say it can happen, but it happens only in the imaginary world. So this would be imaginary solutions. Imaginary solutions are right here, right? So there's no solution here. You can't have it. Okay? Hope this was helpful. Thanks for watching.